that I did, but okay. So yesterday we went over all of the diatomics. We now know how to draw them. I'm going to do something new with you that I've never done before next period, and yes, it's going to be graded. It's a quizzes, but it's not multiple choice. It's going to be short answer quizzes where you actually have to draw these things. So take notes. Oh, that's a lot of groaning. Oh my gosh! Yeah, I know.
Pardon interruption and attention 9th graders and 9th grade presenters. At this time, 9th graders, I want you to take a look at your folders. You're going to be moving over to the session 2, the second session, and you're going to head right over to that classroom. We're going to begin very soon. So again, all 9th graders, say thank you to your presenters. You're going to head on over to your second session. That session will end at 9:55, but I will probably extend it a few minutes. Again, 9th graders head over to session 2, and that will go until about 9:59. Again, you're going to ignore that 4th period bell, and then we'll get you over to your 5th period class. Thanks, everyone.
Okay, put all your phones away. Put everything away except for your reference table, something to write with, and your brains should be turned on. Okay? So yesterday we went through all of the Lewis dot diagrams for the diatomics, and I'm going to quickly just draw them again for you. That way, if I didn't tape yesterday, which I think I did, but I don't know what happened to it, you have them all in your notes. Okay? All of these diatomics had 7 valence electrons, and so they all look the same. I'm using the X's to represent the letters, and then they all looked like this. And then we had oxygen. Oxygen has a double covalent bond. Looks like that. And nitrogen had a triple covalent bond. And I think that's where we left off. Okay? If this looks a little bit too messy for you, you can always use double lines like that to illustrate these 4 dots in here for your diatomic oxygen. And you can use 3 lines for your triple covalent bond. So this is a double covalent bond. And this is a triple covalent bond. Now I saw something happen first and second period today, which I should know it's going to happen, and I'm going to tell you right now so that hopefully you guys get it. Okay? When you go to draw a Lewis dot diagram, the first question you need to ask yourself is, is this ionic or is this covalent? When we drew the ionic ones, you showed a transfer of electrons from the metal to the nonmetal, and then you put the things in brackets. When we draw covalent, there are no brackets. They are just coming together and sharing their valence electrons. Covalent. And before I set you loose on that quizzes that we're going to work on today where you have to draw things, I'm going to give you a few of those. All right, let's do water. Okay? Make a big star. Make a make a smiley face. Okay? We'll put him in a baseball hat. That's a baseball hat. Looks like a pot on top of his head. Do something that makes you remember that this water is extremely important. Because when we draw water, they're going to ask us a bunch of things about that water, so it's important we get the water correct. All right, here we go. When you have a formula, again, ask yourself, is it ionic or is it covalent? And your answer is covalent. Now what we're going to do is we're going to look at the formula and we're going to say, what do we only have one of? In this case, is we have one oxygen. So I'm going to draw one oxygen right here in the middle. And I'm going to put my 6 valence electrons for oxygen on that oxygen in the order that I told you to. 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, 12 o'clock, 3 o'clock. Now we also have 2 hydrogens, each coming in with 1 electron of its own. The only reason I put it up there is because I'm going to move these. So don't draw anything yet, just look. This hydrogen right here says, hey, I need to make a full valence shell. So it needs 1 more. This oxygen saying, hey, I need to make a full valence shell. So this hydrogen gets close enough that a bond is going to form right here. That's a single covalent bond. Let me erase that arrow so you don't get confused. This hydrogen says, hey, there's another spot. Let me go hang out with my friend. And he comes over and he sits right there. This is also a single covalent bond. Okay? There are 4 sites where we are finding electrons. These are right here are called non-bonding pairs. They're electrons that are not forming a bond. There's nothing over here. Sometimes you're going to see them like on the little video, the little thing we're going to do next week, as like a teardrop shape. It's taking up space, but there's no atom over there. And the same thing is happening here. It's taking up space, but there's no atom there. Okay? So this shape of this molecule right here is bent. Kind of looks like an L shape. Okay? That's going to become important as we go on when we talk about shape. So let me just write the shape of this molecule is bent. Shape is bent. Could I highlight that in any way? It's a bent molecule. And it contains 2 identical single covalent bonds. Single covalent bond here, single covalent bond here. That's what water molecule is going to look like. I'm going to draw it one more time for you. So this is what I want you to write in your notes. Here's your oxygen. Oxygen has its 6 valence electrons, and it's going to have 2 hydrogens on it just like that. This is water. Now, I don't know if I said this yesterday. Correct me if I'm wrong. But if you drew water like this, okay, is that water? It is, but it's not drawn correctly. And the reason why, here's a water molecule. Can you see it from the back there? Okay, that's a water molecule. The water molecule, when I'm looking at it right here, looks like this. This water molecule, you're looking at it like this. See the difference? Okay? I don't want you to draw it like this, because when you draw it like this, you are going to say that that is not a bent molecule. That looks like a straight line to me. It's not the way it is. And you guys are only 14, 15, 16 years old. You don't have the experience to interpret this in your head. So the water molecule, I want you to always draw it as a bent molecule, just like this. Okay? And that will happen if you put your valence electrons on oxygen in the way that I told you to, 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, 12 o'clock, 3 o'clock. Okay? And then just put your hydrogens in there. Okay? What shape is this? Bent. Oh, look at that. I don't know what happened there. It is bent. Okay, let's do the next one. That's water. Go ahead. Oh, yeah, sure. You can do oxygen. Remember, every 2 can be a line. And I'm going to end up drawing it like this most of the time. Bam, bam. There's your electrons that are over here. I could also draw it like this. Right? It's just flipped. This is this just rotated. Okay. Are these electrons right here being shared equally or unequally? Uh-oh, Abby's making a face. Is that because you don't know, or you have no idea what I'm talking about, or a little bit of both? Okay, fair enough. Go ahead, Joe.
When you draw like the line model things, do you have to draw the other electrons?
No, technically no. But at this point, I want you to see something that's coming down the pipe. So I'm going to leave those electrons on for now. All right. You've got hydrogen and you've got oxygen. Okay, let's just look at the bond right here. I know there's another hydrogen down here. Okay, look at these two electrons. They're being fought over. They're being fought over by the hydrogen and oxygen. It's a tug of war. Who's stronger in that bond? The H or the O? The O. H is 2.2 as its electronegativity, and O is 3.4 in its electronegativity. So oxygen is a little bit stronger than hydrogen. Because of that, these electrons are not right smack in the middle. They are closer to the oxygen than they are to the hydrogen. Which means that the electrons are not being shared equally. They are being shared unequally. Because of that, okay, the oxygen is slightly negative compared to the hydrogen. It is not strong enough, that oxygen is not strong enough to pull the electrons entirely away from hydrogen like we saw with the ionic bonds, but it is a little bit more negative than the hydrogen is. You understand? Okay, that is called polarity. The oxygen has a slightly negative pole, and the hydrogen is slightly positive. Not entirely negative and entirely positive, just slightly negative and slightly positive. Okay, we'll talk about polarity again in a little while. And the same thing is happening here. You've got this oxygen is pulling closer to it. These electrons are closer to this oxygen than this hydrogen. You okay, Lily? All right, I just saw your hand. I didn't know if you had a question. Okay. All right, let's draw the next one. Let's draw ammonia. What's the formula for ammonia? N8, that's ammonium. Ammonia. You want to move up? Of course. You can always move up. Okay? Ammonia is NH3. We're getting in some nitty-gritty chemistry now. Okay? Sit right here near Ash. She doesn't bite. Not on Fridays, anyway. Okay. So, let's draw ammonia. We're going to put the nitrogen in the middle because it's the one we have one of. We're going to put its 5 valence electrons on. Please tell me you know where I'm getting those 5 valence electrons from. Okay? And I think I said before, I'm not going to spend time explaining where I got those from anymore. We've got 3 hydrogens. I'll do them in red. There's 1, there's 2, there's 3. I just put the electron on so that when I move them, I don't have to move it twice. Okay? This hydrogen is going to move in here. This hydrogen is going to move in here. And this hydrogen is going to come in here. Okay? This is a non-bonding pair of electrons up here. I'll highlight it again. That's a non-bonding pair of electrons. It's still taking up space, but it is not bonded to anything. These guys are single covalent bonds. There's a single covalent bond here, here, and here. Are these sharing their electrons equally? Are they pulling exactly the same so those electrons are right smack dab in the middle? Let's look them up. Hydrogen is 2.2. Nitrogen is, I don't know, 3? 3.0. Are they pulling on those electrons the same? No. So where are the electrons going to be closer to? The nitrogen. Just a little bit. Not a lot of it, just a little bit. Which means the nitrogen is going to be a little bit more negative than the hydrogen. Okay? That's called a polar covalent bond. It's a single polar because I've got a negative side and a positive side covalent bond. I'll define that again as we move along. Okay. Is this a bent molecule? No. Okay. When we make, let me make an ammonia for you. You can see it. You're actually going to make these next week. It's like playing with Tinker Toys. Okay, so here's nitrogen. Here's nitrogen. And here's nitrogen. Okay. This is what it looks like. Can you see that? People at home, this is what it looks like. I know it's hard to see. But that's blue in the middle and 3 yellows. Okay. What does this shape look like? A triangle. Okay. When you have a center atom and 3 around it, it is no longer bent. It is called trigonal. It's a fancy way of saying triangle. It's literally triangle. Trigonal. 3 around it. You see the 3? Now there's 2 different types of trigonals. Regents is not going to differentiate between them, but I'm going to show them to you. Okay? This is trigonal pyramid. Do you see how that center blue one is a little bit higher than the yellows? So it kind of looks like this. You see that? Where all of them are pointing down? That's called trigonal pyramid. It looks like a little pyramid. If I were to draw a pyramid, it would look like that. Okay? There's also trigonal planar, where all 3 of these yellows would be in the same plane. Okay? Regents does not care if you know the difference between trigonal planar and trigonal pyramid, but no trigonal. Okay? All right. That's ammonia. Does everybody have that written down? Okay. Now let's do CH4. CH4. Which atom's going in the middle? C. 1, 2, 3, 4. You got 4 H's. You got 1, 2, 3, 4. Okay, so here's your 4 H's. Each H has 1 valence electron. This H is going to come in here. This H is going to come in here. Oop, I did not judge very well there. This H is going to come in here. And this H is going to come in here. Same thing as what we did before. Okay? Is this trigonal? No. Okay, it looks like it's square. It's not squarinal either. All right. This is what this one's going to look like. Let's see if I can find some more H's in this little kit. Okay, take a look. Does that remind you of a toy that you played with when you were a kid? No? Jacks. Good. Looks like a jack. Because again, we're drawing something in 2D here that really is a 3D structure. Kind of like looks like that. Hold on. Let me pull this up for you so you can kind of see it in real time. Again, you're going to play with this. Okay, clear this. Right, here's my center atom. So in this case, it's going to be my carbon. We're going to put 4 bonds around it. And now you can see what it looks like in 3-dimensional space. Pretty cool, right? All right. No matter how you turn it, it always looks the same. If I do this and I just put 1, 2, 3, and I put a lone pair on it, do you see how it looks the same? But this has no atom. This is the trigonal pyramid shape. And that's with the lone pair showing. If I if I don't show the lone if I don't show the lone pairs, this is what it would look like. That's the ammonia that we were just looking at. See the difference? If I do this, okay, you see that? What do you think that shape is going to be called? Yeah, linear, not lineal. Linear. It's in a line. What about this shape? That shape right here. That's bent. That's water. Okay? Look at water. If we look at the structure that we drew, you see how it has 2 non-bonding pairs of electrons on it? That's these 2 non-bonding pairs of electrons. And if I don't show those non-bonding pairs of electrons, you can see that it's a bent molecule. Okay? Let's go back to our CH4. All right. What's the name of this shape? This shape is called tetra. Tetra meaning how many? 4. Hedral. A tetrahedral molecule has a central atom and 4 around it. Tetra, 4 around a central atom. Tetrahedral. Let's zoom into this bond. Is this bond sharing electrons equally or unequally? Hydrogen is 2.2 and carbon is 2.6. They're unequal in sharing. Where are the electrons going to be closer to? The carbon, because carbon is just a little itty bitty bit stronger than the hydrogen. See that? Okay, let's recap. H2 kind of looks like this. I'll draw it like this. H bonded to H. What's the shape of that? Linear. Anytime you have 2 things that are in the same, they're going to be linear like that. Okay. Water. H2O. That's going to be bent. Ammonia. NH3. That's going to be trigonal. And then anytime you have something with 4 around it, like CH4, Cl4, CF4, those are going to be tetrahedral. Okay, that's your shapes. Linear, bent, trigonal, and tetrahedral. Go ahead, Will. It can. There's trigonal bipyramidal, there's octahedral, not in Regents Chem. So, Regents Chem, I'll tell you what the answer is going to be. Okay? 99% of the time it's going to be tetrahedral. Every once in a while they'll throw a bent molecule in there. But most of the time, if it's an answer choice and it says tetrahedral, you should be picking it. Okay? Okay, let's get back to the molecules. All right, go ahead. Yeah, sure. I'm going to put these electrons on here just because. We good? Lily, good? Okay. All right. The other thing, did you watch the Ed puzzle yet? Okay, we're going to do that in a few minutes if you haven't done so already, but let's go over it. Naming covalent compounds. When you go to name covalent compounds, you're going to use prefixes. We did not use prefixes for ionic compounds. So every time you go to either name something, draw something, whatever, especially now that I've introduced covalent to you, your first question to yourself should be, am I dealing with something that's ionic or am I dealing with something that's covalent? If you are dealing with ionic, okay, and let's say you had MgF2. If you had this and you say to yourself, self, that's ionic because I know it's a metal and a non-metal, and I ask you to draw it, I'm talking about drawing the electrons. I'm talking about showing that the electrons are being transferred from one to the other. This is what we did. This is where the wheels start falling off the bus, guys, because you forget what we did a week and a half ago. And then I say, all right, finish it up. Put it in brackets. Put the charges on just like we did last week. And I know that I had 2 fluorines, each with a -1 charge. That's what it will look like if I ask you to draw an ionic compound. If I say name it, you're going to say magnesium, fluoride. You're going to ask yourself, does it need a Roman numeral? You look at your periodic table. Magnesium only has 1 choice, so it does not need a Roman numeral. Okay? Covalent is different. Covalent, let's say I put a covalent one down, and I say CH4. Oh, I forgot to draw carbon dioxide. Okay, we'll do that in a second. If I say CH4, and I say draw it, I don't want to see any brackets. I don't want to see any charges. It's not ionic. It's carbon with the 4 electrons, and you're going to put your 4 hydrogens on there. That's covalent. Now, if I go to name it, I'm going to name it with prefixes. Now, what are my prefixes? Prefixes are 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta. That's as high as I'm going to go right now. Okay? So if I want to name this, I have 1 carbon. Because that carbon is the first one in the compound, I don't use the word mono. I just say carbon. And I've got 4 hydrogens, so I say tetra for 4 hydride. tetrahydride. Okay, let's do another one. You need more time on that? Are you okay? Alright. Since I didn't draw carbon dioxide, and it's probably one of the most important ones, let's do this. Name it. Carbon. It's covalent now. I need prefixes. Di for 2, oxide. Carbon dioxide. What about CO? Carbon. What? Monoxide. Mon for mono, which was 1, oxide. What about P2O5? How many P's do I have here? 2. Diphosphorus. Pent oxide. SF2. Sulfur. What's F? Fluoride. Sulfur difluoride. CCl4. Carbon. What's 4? Tetrachloride. Na2S. I knew I was going to get you. Is it ionic or is it covalent? Do you use prefixes for ionic? Gotcha. Okay. First question you should be asking yourself, is it ionic or is it covalent? So this is sodium sulfide. Does it need a Roman numeral? No, because sodium is a +1. Okay, that's what's going to happen, and that's what makes this so hard. You have to remember all the things we've done before. All right, I forgot to draw carbon dioxide. We've got to draw that one. All right, carbon dioxide. What element goes in the middle? Carbon. We've got 2 oxygens. Here's your 4 electrons for carbon. Oxygen has 6. 1, 2, 3, 4, 5, 6. So here's your oxygen. Let me just move this away. See it? Okay. It's going to come in, it's going to bond with this carbon. It's dioxide, so there's going to be another oxygen. 1, 2, 3, 4, 5, 6. When you look at this carbon dioxide, is this oxygen satisfied? Does it have 8 valence electrons? No, it does not have 8 valence electrons. Count them. 1, 2, 3, 4, 5, 6, 7. Okay? This oxygen doesn't have 8, and this carbon doesn't have 8. We need to move them around so that they have 8. Just look, don't write. You see this electron and this electron? They are going to move, just like we did with the nitrogen and the oxygen. They are going to move so that they are in between the carbon and the oxygen. That's a double covalent bond. This one is also going to move. So you've got a double covalent bond. Now everybody is satisfied. Carbon dioxide has 2 double covalent bonds. Two double covalent bonds. Here's a double covalent bond. Here's another double covalent bond. Let's draw it with the lines instead. It's a little bit easier to look at. And then you've got your non-bonding pairs of electrons out here. Know how to draw carbon dioxide. Please. I'm begging you. Go ahead, Nick. Yep. Say it again.
For specific ones, is it going to ask you, or can you do whichever, like with the lines or the dots?
Oh, no. It won't matter. It will not matter. I would do this one if I was you. Okay? It's easier. However, if they ask you for a Lewis dot diagram, make sure you put these dots out here. Okay? What shape is this? Linear. Good. It is linear. I know it doesn't look like it should be, because when you look at water and you look at carbon dioxide, you would think they're the same shape because they have basically the same numbers on the bottom. That is not what is happening here. Okay? The water is bent because the lone pairs of electrons, the electrons that are on that oxygen, that are here, right here, and right here, they are pushing those hydrogens down. There are no non-bonding pairs of electrons on this carbon, so there's nothing pushing these oxygens closer to each other. That's the difference. Okay? All right, I gave you a lot today. How do you feel? All right, let me stop the tape, and then next period we're going to practice these.